Hi, it's Miss House. Now let's take a look at how we actually can calculate the instantaneous rate of change. So remember that the instantaneous rate of change is the slope of the tangent line, 1 point. So it's the slope of the curve at exactly that 1 point. This is called the instantaneous rate of change. And what we're going to do to actually calculate this is we're going to start with 2 points. We'll call the first one x sub 0. That just means initial value of x. We're going to pick a second point that is exactly a distance of h away, just an arbitrary distance. We don't know how much it is, but we know that this second point would have to be at this first point plus h. Think about it. If this is a 2, and we move over 3, this would be 5. 2 plus 3. Now that means the function values, if x is at x sub 0, then the function value is f of x sub 0. That's your height of your curve at x sub 0. And if your x value is x sub 0 plus h, then the height of your curve is at f of x sub 0 plus h. Now, if we have a line between those 2 points, okay, that's not the instantaneous rate of change. Remember, that's your secant line, your average rate of change. So what we want to do is we want to take this first point, this second point at x sub 0 plus h, and we want to move it closer by reducing the value of h. So instead of being at x sub 0 plus h is getting smaller and smaller and smaller and smaller until h is actually 0 and that the point is at one exact place. Now let's calculate the difference quotient. Remember the difference quotient? That's basically, it's the slope formula, right? We call it the difference quotient. So think about what we have. We have our second y, f of x sub 0 plus h, subtract f of x sub 0. All of that will be divided by x sub 0 plus h, subtract x sub 0. It's exact same as the slope formula. It's just in new notation. So this will give us f of x sub 0 plus h minus f of x sub 0. And what happens is, when you subtract these two, you end up with a denominator that is just h. That is called the difference quotient. Now what we're going to do is we're going to look at what happens when we let the h value get smaller and smaller and smaller, and ultimately we want to find it when h is exactly 0. We'll talk about that in another section, but we're going to do a limit and we're going to let h go to 0. So the actual formula for what we call the derivative, which we'll do in the next section, is the same formula, but we're going to look at the limit, like we've looked at limits before, of what happens when we let h go to 0 of this difference quotient. And we won't even call it x sub 0 anymore. We'll just call it x. And that is actually your formula for your instantaneous rate of change when you have a known function. Okay, and we'll do that again in the next section. But what we're going to do in this section is we're just going to let the h get closer and closer to x sub 0. So we won't do it exactly at 0 yet, because you can see, look, h in a denominator would be a 0 denominator, which we can't have. So we'll have to learn how we can do this limit without actually having a zero denominator. All right, so let's look at a couple of these. It says calculate the difference quotient for f of x equals 5 minus 3x using h is 0.1, 0.01, and 0.001. Use the results to approximate the slope of the tangent line of f of x at a point 6, negative 13. If necessary, round the difference quotient to no less than 6 decimal places and your final answer to 2 decimal places. Okay, so let's do this and then we'll see what kind of conclusions we can come to. So remember, our difference quotient is f of x sub 0 plus h minus f of x divided by h. Now here, what we have is a value of h is 0.1. That's the first time. Then we'll do h is 0.01. And then we'll do h is 0.001. So here's what we're doing. We're moving that h backwards. All right, this whole distance is h, and it's getting smaller and smaller and smaller, so that this point here is moving back over here to this point. Okay, so that's exactly what we're doing here. Now, they do give us an x value that we're going to start with as a 6. So the first one would be, so x sub 0 is 6. That's where they want us to find the slope of the tangent. So f of 6 plus 0.1 minus f of 6. Remember, we're using, and that should be this should be a 0 right here also. Okay, divided by h is 0.1. Okay, so remember, we're calling x sub 0 6, and there's our difference quotient, and we've got to actually do some calculations. So I have to do f of 6.01, and then the next time I'm going to have to do f of 6.001, and then I'm going to have to do f of 6. Whoops, this one should be 0.1, and then 6.001. And I'm going to have to do that in this area every time, so I'm going to go ahead and, oh, and we also have to do f of 6, so let's do f of 6 also. And then we can just plug it into the formula. Okay. So here's my function, 5 minus 3x. So 5 minus 3 times 6.01. 5 minus 3 times 6